Right, in section 5, we're going to just be reviewing how to solve what are known as simple inequalities. We use the word simple not to say that they're easy, just to say that there's only one inequality symbol in the problem. Okay, I'm hoping that this particular unit or the section will be review for you. So notice here we're just asked to review how to graph inequalities on a number line. Okay. Let's suppose I want to say x is less than 5, meaning I want to graph all real numbers that are smaller than 5 units on the number line. How do I represent that? Well, first let's label here. I'm going to make right here 0. 1, 2, 3, 4, 5. Throw some negatives in there. And if I want all numbers less than 5, that does not include the number 5, right? But I have to visually go all the way up to the value of 5. So I do that by using an open circle on the number line and then drawing an arrow in the negative direction, meaning I'm moving to values that are smaller than 5. Okay. Y is greater than or equal to negative 3. So once again, let's label here. I'll put 0 more towards the center this time. Always label your number line with integers. And just understand that in between the tick marks and the integers are an infinite amount of rational numbers, irrational numbers that represent decimal approximations. All right, y is greater than or equal to negative 3. That's including negative 3. If I want to include a value, I use a closed circle, and then greater than would mean values that are to the right of negative 3. All right, and then the next and last one here, this is not what you would consider a typical inequality symbol. Z does not equal negative 3, but understand that really does represent an inequality. That's talking about an infinite amount of numbers other than negative 3. So how do I put that on the number line? Well, it's labeled just like we did before. And I know if I don't want to include negative 3 at that exact spot on the number line, I can put an open circle. But I do want to include all numbers that are larger than negative 3 and all values that are smaller than negative 3. So I can designate that by putting an arrow both to the right and to the left. All numbers except for negative 3. All right, here is a very typical simple inequality. Right? Notice it looks a lot like an equation, except instead of the equal sign, you have an inequality symbol. Right? I'm going to solve this very similar to how I solved an inequality or an equation. I'm going to move my variables to one side and my constants to the other. Okay. So that's going to result in negative y is less than or equal to 5. And then to get y alone, you can either multiply or divide both sides by negative 1. Now recall, you should have learned this in an earlier course, when you multiply or divide by a negative number inside of an inequality, you have to flip your inequality symbol. So here is our solution set. Let's write that property down. All right, here's a question. Do you know why that is? Well, let's take this example into play. Would we agree that -2 is less than 2? I think that's a true statement, right? Now let's treat it like -1 times 2 is less than 2. Still a true statement. Let's divide or multiply both sides by -1. On the left side, you will get 2. On the right side, you will get -2. If you just carry down the inequality symbol, you would have 2 is less than -2. That is not a true statement. You have to flip the inequality symbol for it to be a true statement. So there's your explanation as to why to divide, or why to flip the symbol when multiplying or dividing by a negative. All right, back to our solution here. We need to graph it. Okay. So let's see, I got to fit -5 on there. I'll put that in the center. -4, -3, -2, -1, 0. All right, we want to include -5 in the solution set, so give me a closed circle at -5, and we want to also be any number larger than that. That would take us in the positive direction to the right. All right, give you another example here. I want to begin by distributing that -2. Or you could divide it out. It's up to you. 12 is greater than or equal to -6n minus 2. I'll add 2 to both sides. 10 is greater than or equal to -6n. Now I'll divide by a negative. And 10 doesn't divide evenly by -6, so let's just reduce here. So that's going to give me -5/3. Don't forget to flip your inequality symbol. Okay. All right, now, the way my work took me here, I ended up with my variable staying on the right-hand side. I personally don't like that when I go to try to graph and reason out which direction my arrow should point. So I'm going to take this and I'm going to reverse everything. Put the variable on the left, which requires the inequality to flip, and -5/3 on the right. So there's my solution. Now let's try to graph it. All right, once again, label your number lines with integers. Even though your solution has a fraction to it, you still should be labeling with integers, right? So let's show 0 in the center. Get your negatives in there. Right? And we know that this is equivalent to saying n is greater than or equal to -1 2/3. Here I think is an appropriate time for a mixed number, right? That's helpful to see that my on my number line, I should be placing, in this case, my closed circle between -1 and -2. it should be a little bit closer to -2 than it is to -1 because of the 2/3. And then my arrow from there should point to the right. Okay. Last problem, bit of an application here to inequalities. Joe has at most $15 to spend today. He buys a bag of chips and a can of soda for a combined total of $1.59. If gas at this station is priced at $2.89 a gallon, how many gallons of gasoline to the nearest tenth of a gallon can he buy? All right, so word problem. Really good for us to define a variable to start things off, right? So I'm just going to use the variable x. What does it represent in this situation? How many gallons of gasoline? Okay. And we need to write an inequality here. Okay, so the way this is set up, he's buying a bag of chips, a can of soda for $1.59. So that's a fixed number. And you add that on to the price or the cost of the gasoline. So it's $2.89 per gallon, right? And all together, that needs to add up to at most $15. Okay, so there's an inequality symbol that can be used here. It would be great if he didn't spend all $15. He could spend less than it, but he doesn't want to spend more than it, right? So that means the inequality implied here by at most is less than or equal to 15. Okay, so let's solve here. Subtract the 1.59 over 2.89x is less than or equal to 13.49. Then you can divide over your 2.89. And let's see, what do we get here? 13.41 divided by 2.89 is 4.64 to the nearest tenth of a gallon. So that would be 4.6 gallons. Okay, that means he can't go over, he can go up to 4.6 gallons. He just can't go more than 4.6 gallons.